There we go. All right, so this is a telnet session using secure CRT into CMTS box in Atlanta. So I have the old SA, Scientific Atlanta, Cisco lab down in Lawrenceville, Georgia, outside Atlanta. And I have a CMTS there we use for customer proof of concept, as we call CPOC. Here's a command I run to see any modems in partial service. This modem is /P, means upstream bonding partial mode, and it's doing 8x3, and it's telling me I have an impaired channel on upstream 3. What I did, if we look at a show cable hop, some of these commands I'm running are shortcuts that I made called aliases, and I'm going to look at upstream cable 202. This is on a CMTS called a CBR8, and I run this command real quick just to show my upstream spectrum allocation. So upstream 0 is at 16, 22.5 for upstream 1, so I made them all 6.5 megahertz separated. It was easy math for me to do, and I wanted them at least 6.4 megahertz separated. But look at my last upstream 3 is at 44.5 megahertz. So I am getting some uncorrectable FEC, some correctable FEC. It's at 44.5 megahertz. I do have pre-equalization on, but I turned it off for one specific modem. So for one modem, I excluded it. So under my cable interface, I have cable pre-equalization exclude modem with a MAC address. So this modem is not doing pre-EQ at all on any of the upstreams. And it will especially be bad at 44.5 megahertz. Now, in my lab, I don't really have a diplex filter, but I'm starting to run into the built-in filter of the modem. So if I look at show cable modem and pull up this MAC address, and I have a command called PHY for physical layer, I can see that my upstream power is also transmitting much higher at upstream 3 because it has to overcome the loss of its own filter. Also, the MER is only 26 dB on upstream 3, but it's 38 and 39 on all the other upstreams. So even though I'm not running pre-Q at all, my upstream MER is still good at upstream 0, 1, 2, 0, 1, and 2, but upstream 3, you can see the MER is pretty poor because of that roll-off, and the pre-EQ is not doing anything for me. When I look at the verbose command of this modem, there's a lot of information here, hence the name verbose. When I pull this information up, we have another feature just coming out. It's not actually released yet. It's called data burst resiliency. And what we're doing is looking at the upstream data burst MER along with the station maintenance MER. Now, the station maintenance MER we've always done. This is the station maintenance MER. And you can see here it says 25 dB. That previous command was showing 26, so that's updating every 20 seconds or so. But my data burst MER, I don't really have any data running on this modem, but it's reporting 16. I have this new feature that when I exceed a user configurable threshold on this data burst MER and my uncorrectable FEC gets above 1% for this modem, I'll mark it as data burst resiliency suspended. So this modem goes into partial mode. It gets marked /P like we showed. Where is it? Right here, and I can see which upstream is impaired. So this is a nice feature for me to put the modem in upstream bonding partial mode when I know the MER is poor enough that 64 qualms is not going to work. So I set up my thresholds for 23 dB MER, and I also said don't go out of partial mode unless it gets above, say, 30 dB. So I have a little hysteresis I can set up there. So now this modem's in partial mode. I'm going to turn on pre-EQ for this modem. So where's the command at? Here. I'm going to do config terminal. I'm going to do a no. So now this modem should be allowed to do pre-EQ. We're going to look at the phi command. Might take 20 seconds or so to update. So right now, it's funny, it's like the level actually went up a little bit, which kind of makes sense, right, Brady? We talked about this.
Yeah.
When we turn on pre-EQ, the built-in equalization will kick in, which could make it have to transmit higher.
Well, yeah, and it's getting roll-off from the diplex filter. So it's getting attenuated basically by the diplex filter, so it has to increase its transmit power, which pre-equalization, the CMTS is going to see it attenuated by the diplex filter. So now,
well, that was my original 48.5 was because of the roll-off of the filter. Now, not only do I have the roll-off, but I have the pre-equalization kicking in, which jacked it up from 48.5 to 50.25. And that was my point, is my upstream transmit actually went up even more than what I had before.
right.
But notice my MER got better as well. Now,
What was your original MER? Your original MER
was 26, 25, 26. So now if we do look at the modem, partial service, it still says partial service. Let's look at verbose for this modem. And the data MER still says low, but this MER went above my 23 dB, plus I had a 6 dB hysteresis. So we figured one of the modems partial will never be any data, so we can't rely on the data MER anymore. So we look at the station maintenance MER, because that'll always be there. That went above my 29 dB, so this came out of partial mode. So now if I look at partial service, partial service, there is no modems in partial service. So this modem is no longer in partial mode. If I look at this modem and say wideband channel, I can see it's in full 8x4 mode. So this is the beauty or the power of pre-EQ. I turned on pre-EQ. It made up for this roll-off. Yes, this modem is transmitting kind of high, almost the max output of 51, but it's transmitting 50. It's all the way down at 43 here. That's like a 7 dB difference in level between the upstream channels, which the spec says they're allowed to overcome 12 dB, called dynamic range window. So, I mean, it's still working. The MER came up quite a bit. 64 QAM will still work. If I started running data here on this modem, I would suspect this data MER would come up as well. Right now, there's no data running, so there's no real need to upgrade it or update it. I might see it update once in a while. Now the data MER says 30 dB. So it did upgrade. And that's probably because it was doing something else in the background, like a DHCP renew or something like that, where data was actually sent. Does that make sense?
Yep. I mean, I think so. This is one of the things that the discussions that I get into customers with a lot of times, because this is awesome. You're a maniac, first of all, for running a modem at that high a frequency, of course, and you're a maniac for other reasons, but that's cool with me. But I mean, pre-EQ brought this modem out of partial mode, got relatively good upstream SNR. Now, the PNM application would show you have crazy group delay on this modem. So it would probably show this modem as a red modem. And one of the
in-channel.
Yeah, and it would show
in-channel
really bad in-channel frequency response as well. One of the conversations I have with cable operators a lot of times, especially when they're doing 4-channel upstream bonding like you are, is you have group delay. The modem is red. We can, but this may be something that you want to continue with, and we can change thresholds to change that modem from red to green if you want to keep that modem at the frequency that it's at with group delay, because we are stuck with a 42 megahertz return for the time being. You need the bandwidth that you have, and pre-equalization, I mean, that's going to be a steady state condition. It's not like that pre-equalizer or that diplex filter is going to change unless, like the example I had where we had the capacitor that popped off. That's a different condition, but for a steady state condition where we know what the group delay is going to be, we know that the cable modem is not going to be changing frequency, we may elect to run cable modems with a certain amount of group delay and just consider that an acceptable condition, because we know pre-equalization will keep running. It is going to take away from some of the reserve of the pre-equalization in the cable modem, but we may have to consider that a necessary evil until at some point in the future where we increase the return path to, say, 85 megahertz or 200 megahertz, looking forward to DOCSIS 3.1.
This is another good point, and I brought this up at SCT last year, was I had a DOCSIS 3.1 modem, and they have configurable diplex filters. So you can configure what you want. It was 5 to 42 or 5 to 65, 5 to 85, or 5 to 204. Now, we added preliminary modems, pre-release modems, and there was a couple of bits flipped on some type of registry or whatever, and we did 5 to 85, and it was like the 5 to 42 filter and 85 filter kicked in at the same time, and there was this big suck out right at 42. So I had one of my upstream channels doing 8-channel upstream bonding, and one of those channels was right over top of that 42. Now, pre-EQ made up for some of it, but I had poor MER. Now here you're scratching your head and you're thinking it's a plant issue. How do you prove it's just a modem issue? One of the nice features, and you could probably talk about this as well in your later slides, was the modems, the new 3.1 modems have the capability to kind of do their own upstream sweep. So you could sweep across the spectrum of that modem itself, and then you could, with the either downstream spectrum view of the modem or the new upstream spectrum view of the modem, you can see what that looks like. So even though we assume most of our problems are in the plant, it could have been the modem's filter was a problem. In this case, it actually was. It was because of a preliminary modem with 2 filters kicking in at the same time, causing a suck out. So it was an interesting way to see how, the modem filter itself could have been an issue, and pre-EQ could either mask it or I could use other features to track it down.
Yeah. I mean, so I think I have a different slide deck for PNM and DOCSIS 3.1, but to your point, everything we've been talking about so far with DOCSIS, with PNM and DOCSIS, it's kind of been reverse engineered. In the DOCSIS 3.1 specification, PNM has a whole complete section devoted to it because it's just been so valuable that when they wrote the DOCSIS 3.1 specification, they said, well, we're going to build it in, we're going to define it, make sure everyone's standardized, and we're going to have a bunch of new features. The one feature that John is talking about is the ability to sweep your cable plant using the CMTS and cable modems. And so it's an awesome feature. So, one of the challenges, especially with the return, is if you're doing like 4-channel bonding in the return, it's really hard to put sweep points anywhere. Well, we kind of fixed that with DOCSIS 3.1 because we can sweep the return with a DOCSIS 3.1 cable modem in the CMTS. So that's an awesome feature.
So there's one more thing I wanted to bring up, and I'll give it back to you. You and I talked about this, and you kind of put a thought in my head, and we're talking about the T4 multiplier, how when we do upstream bonding, we have this T4 multiplier to alleviate the number of station maintenance bursts that go to a modem. So suppose at your house you have a modem, and we want to keep that modem alive, but why would I quadruple the amount of overhead of station maintenance to your house? If you have 4 upstreams all doing station maintenance, maybe I can drop each one by a factor of 4, and you still end up with the same amount as if it was 1 upstream channel. Meaning, if I have 4 upstream channels, I'm going to do 4 times 20, meaning I'm going to do station maintenance to every upstream every 80 seconds. That basically means you got 4 station maintenance in 80 seconds, which is 1 every 20 seconds. So you're back to as if you're DOCSIS 2.0. So the problem with this is, and this actually, I'm going to San Jose next week and talk to some of our own engineers, and I'm bringing this up to have a feature request, is if station maintenance is only sent 80 seconds in this example, you're not going to get a pre-equalization update for 80 seconds. You're not going to get...
worse when we do 8-channel bonding. And
yeah,
there are customers that are doing 8-channel bonding in the upstream.
Exactly. So you exacerbate the problem by going to 8 channels, and now it's 8 times 20 is 160 seconds, which is 8 times 20. 160, which is 2.5 minutes or whatever it is, 180 seconds or 3 minutes. So either way, you're not getting pre-EQ updates, and you're not getting station maintenance MER updates as well. And if I'm relying on my station maintenance MER to get me out of partial mode, it's going to take me even longer to get out of partial mode when I do have a problem that goes away or whatever. So I brought this up, and we're thinking about maybe allowing a different station maintenance for pre-EQ versus levels and frequency and timing, or maybe we have something that cuts it in half, or maybe we just recommend a lower amount. Right now, it turns out it's dynamic, and if a modem is doing 2-channel upstream bonding, the multiplier is 2. If the modem is doing 4-channel upstream bonding, the multiplier is 4. Well, maybe I'd want some type of correction factor to say modem's doing 2, actually do 1. Modem's doing 4, do 2. Modem's doing 8, do 4. You understand? Like half the amount.
Yeah, and it's a really, really important point, John, because some people will say, well, 2-3 minutes, what's the big deal? That should be enough to update the pre-equalizer. But in reality, if you think, on a windy day, a piece of coax cable on a strand is blowing back and forth, that's changing the impairment every time that cable moves back and forth. We want that pre-equalizer updating as fast as we can. I'd like it updating every 15 seconds.
Yeah.
And so when you're talking about 4-channel bonding, and now it's going to be 4 times 15 seconds, that will have an impact on subscriber experience. So
we think about the speeds we're doing. Let's suppose we're doing 50 megabits per second. That one upstream goes down, and we don't mark it down quick enough, it doesn't go into partial mode, we're allocating mini slots for that upstream, and it might be just dropping it for however long it takes to get an update, and if that update takes a minute, you lost an entire minute. So 50 megabits per second times 60 seconds in a minute, you lost a lot of traffic.
Yeah, so it's not a trivial thing. It's not a trivial thought. I think it's really important that you do drive this, and this becomes something that probably should be taken back into the Cable Labs and Genius working group, and then pushed out to all vendors.
Yeah. So really that's all I had, and I thought I'd bring that up and keep you updated, and that's all I had for now.